So, if you could kind of just go over the problem that we are going to be discussing, kind of putting together maybe even the problem statement and then kind of your approach. If you could start by talking about that, that would be great.
Okay, yeah, so we're going to be going over the depth first search, and let me get the code interview back up. And basically, with depth first search, so it's a graph algorithm. You're going to be traversing a graph, and then what we're going to be doing is basically taking the nodes and organizing them from like in a depthful manner. So I guess for example, so if I kind of illustrate, so if we have a graph that's let's say the root node is going to be A, and then that branches out to B, C, D, and then B is going to hold two children nodes. We're going to label them E and F. This probably isn't the best way to try to illustrate this. And then C is going to have no connectors, and then D we're going to have G and H. And if we go down one more level, we're going to have F is going to be attached to two nodes, I and J. And then G is going to be connected to K. Um, in this algorithm, we're going to be going through and we're going to be connecting, mind you, A is the root node. It's going to be connected to B, C, and D. B is connected to E and F. F is connected to I and J. G is connected to K. H is a standalone. We're going to have to do this recursively. And then also to kind of illustrate, I think we should take a step back to kind of give everyone an idea of what a graph is made up of. A graph is going to have we're going to have a node class, and inside of that, a little different, that each node is going to have a name. And then each of those nodes is also going to have a list of its children. So we have this dot children is going to be equal to an empty array. And inside of the array, you're going to have each of those additional nodes. So let's say we had A. A is going to have the children of B, C, and D. And each of those children are going to be nodes themselves. And those children are going to have, if they do have children, then they're going to have like children as well. If not, then it'll be an empty array. And then we'll be able to iterate out of that, out of the actual search. Am I kind of missing anything, or is there anything that you want to kind of clarify?
I just wanted to say, so the graph is a data structure that you're using, right?
Yes,
Okay.
yes.
Um,
How was your studying this weekend?
it was okay. I kind of focused a little on learning React as well because I'm contributing to an open source project and I'm using React for it. It's kind of my first time, so I'm learning as I go. I kind of
Yeah, if you
like.
need help with React, I'm definitely way better at React than this.
Thank you.
Are you all using classes, or you just using functional components? Do you have like a certain standard you're using?
For React.
Yeah, so like you have like, so it just depends on. Sometimes more people are more comfortable just using hooks, and that's all they want to use. So you have like class components, you have your functional components.
Oh,
It
interesting.
just depends on. You're probably if you're learning on your own, you're probably using classes, which is good.
I'm kind of contributing to an open source project, so it's an existing project, and what I'm doing is like I've picked an issue and I'm kind of trying to figure out how to solve the issue. So I'm not really like starting the
Oh, okay.
project from scratch on my own. But it's good to figure out if they're using function or class.
Oh, yeah, because it's completely different approaches.
Uh-huh.
And the React lifecycle works a little bit differently.
Interesting.
And you're going to Octo? Is that like a what is that?
Well, it was Outco. It's a program that's kind of prepares you for any kind of technical interview. Um, so the goal is for you to have some sort of like improvement in your career, whatever, whichever it is. Like if you're like midway through your career, you just want like a higher paying job, or like you just want to raise at your work, or you just want to like get better at like technical interviews, you want to learn algos or like data structures or something like that. It's basically like a month long program that helps you with all of that. Like they teach you about anything about interviews, kind of like job searching cycle, whatever you're supposed to do, like reverse recruiting, how to like go about that, and like how to basically do all of the algos and like data structures that are needed for interviews. So
Yeah.
I finished it. It was actually this week was my last week.
Did you learn a lot?
Yeah, I still have to go back and review so much. Not even review, just study. But but as I study, I learn a lot. Okay, so is that the problem statement?
Yes, this is the problem statement.
Okay.
So given a node class um, that has a name and an array of children, like so, when put together, the nodes form an acyclic tree-like structure, which is annotated above. Implement a depth first search method onto the node class, which takes an empty array, traverses the tree using a depth first search approach, specifically navigating the tree from left to right, and then stores all nodes in the input array and returns it. So to solve this, so we have our constructor, our node class, and inside of our node class, we also have a add child, and this is what is making up our graph or our node data structure, which is going to make up our graph.
Okay.
Um, Now, add child, it's going to grab onto whatever this is. Children, it's going to push in the new nodes. So every time you're adding on, it's going to be able to push. And then for the depth first search, so we're going to actually, inside of our data structure, so we have our, or we'll just abbreviate it DFS.
Mhm.
And DFS is going to take in an array. And then inside of that array, we're going to have array dot push, and then this dot name. And then we're going to do a for of loop, and then we're going to go through each child. Of this dot children. And on that child, we're going to call the DFS function. So we're going to do the depth first search. And call that array. So right here, we're taking in, our function is going to be taking in the array, whatever that array might be. So if we had a two-dimensional array that represents our graph structure, it's going to go through. and we're going to grab onto that array, and we're going to go ahead and push whatever the name of that array is. And this is being called recursively. So once we get into our actual child function, we're basically reorganizing from like how the child nodes are set up. So we have our root node, and then we have our children nodes, and those children have children. It's going to reorganize this list up here and return to us an array of everything in order instead. Like so, it takes it out of being in the format of a graph and transforms it into an array. So we get A, B, E, and then F, and then I, J, C, D, G, H,
Okay.
or G, K, H. With the depth first search, I want to kind of turn it over to you a little bit, and what's your understanding of how recursion works inside of the depth first search?
Well, I know how the first kind of works. Like it goes through uh, the depth of the graph one by one and pushes inside the array. But if I want to look at the array the DFS function that's down there, it's a little confusing to me. So maybe we can walk through each
So it's kind of
line. Yeah.
yeah. So I mean, I think I understand how this is working.
Okay.
And it is complicated. So we have to really understand that we have our depth first search, and that's going to be taking in an array. Now, initially, this array is just going to be because we're within our graph. Like this is a function that we're calling inside of our graph. We're taking in. We have an empty array, and we're going to push whatever this dot name is.
So this that
So
name here is like the node, right? Which starts from A.
exactly. So
Okay.
array dot push, and then this dot name. This is going to be referring to that root node, which is going to be A, or that starting point. And then it's going to it's going to go through, and we're going to grab each child of this dot children. So this is like, if you're not familiar with like a for of, um, I don't really like them too much, but it's just a for loop. You're grabbing each index in the array from 0 to n, and you're just going to grab each of those indexes. So each index holds another node that is a child. That's the child of the parent. Then we're going to call DFS, and we're going to keep passing in that array. So this is that same array. When we go back through, we're on the child node. So the child is now like referred to. This dot name is referring to whatever that child node was.
Okay.
And then we're pushing it. At the same time, it's going to be grabbing whatever those children are. Now, this is like scope, and each of these functions, like I'd like to think of it as they're all happening at the same, like they're affecting the same, like they're all affecting the same array, but they're kind of individual. So I mean, our for loop ran through. It's calling DFS however many times for however many children there are within that. So when we go through the first time, it's going to be calling child on B, C, and D. And each of those are going to be running through their own. So it calls child B first. So it goes through for A, and then it's going to do the child of this dot children, and then for A, or it pushes A. It goes through, and then the first time it calls, it's going to say child, which is equal to B. Like child is a node with the name of B and has the children of E and F. So it's going to call that, and it's going to call DFS.array. So it keeps on passing that same array. It's still referencing the same array. And then it's going to go into C. It's going to go into D. It's going to go all the way. It's going to finish all the way through with that first call of B before it starts actually iterating through the rest because we're dealing with I want to say that has to do with it has to do with like the call stack, and that's how synchronous programming works. This isn't only one thing can happen at a time, so it's each of these are going to have their own stacks within memory.
Uh-huh.
They're all referring to the same array, so it's going through. It's hitting A, and then after it hits A, it's doing the for loop. It hits B. It's going to hit B, and then it's going to hit E. It goes back through. It hits F, I, J, and then it goes back down and hits C. Because of how the call stack's working and how does that kind of make sense? And
Yeah.
I think this is kind of learning for both of us.
Mm-hmm.
A lot of this I'm kind of it's what it seems to me from what I know and how I understand recursion, which might not necessarily be correct. So please correct me if I'm wrong.
I'd actually heard about the call stacks as well. Like, not heard, but like I was familiar with it. So this kind of makes more sense seeing it here.
It's really funky. Like it's like being able to visualize recursion and just jump into it is it's a really funky thing. Binary. This week I'll actually be going over the binary tree and all the methods, and we're going to be going over binary trees, binary search trees, and that's really going to help kind of divulge the mystery of how recursion's working.
Yeah.
Um,
You're
but
referring to the
what,
morning sessions, right? The morning
yeah,
algo
yeah, and
sessions.
that's something I made just so really so I could learn. We learn better by teaching,
Yes,
and
exactly.
yeah, also there's people that are way smarter than I am, and if I can get them to understand things faster than I can, then they can teach me along the way also, because it's hard to find people that want to learn algorithms, and it's not hard to find them, but it is hard to find people that are willing to wake up an hour early or whatever and put in that extra time.
Yeah, I
But
agree. Um, well, so back to here. So basically, the for loop, when we call the for loop, so let's say, kind of go over one cycle from A to like the very first branch. So the very first time when we push this dot name, we're pushing A, right? And then when we go for const child of this dot children, so um, this dot children is going to go through. So I'm gonna highlight this method over here at children. Am I correct?
no, so this dot children is referring to. So right here we have our constructor, which is our node.
Okay.
So and then outside of our constructor we have, and I want to make sure. See, one thing that I did jack up that kind of is throwing. Is that throwing everything off? No, this is fine. So when it goes through, so we have an empty array. When it gets to this dot children, it's talking about the like the instance that it's in. So when we first go through, we've called this on whatever that initial like this dot name is. So the first go through, it's array, and then it's calling this dot name, and then it's going through, and it's calling a different. It's referring to a different this. So it's going the first time we go through. So we'll just name this A,
Uh-huh.
and inside of here we have B, and then B is holding an array or an object that has an array of children, and those children are going to be E and F. And the same thing is going to be with C. So C is just going to be C. Children is just going to be an empty array, and then D, which is going to be children with an array of G and H. And this is what this is a constructor, so this is already built out, and I wish we had, a way to kind of like illustrate the code a little bit better, and kind of like, and test it out would also be great. But so if this is with our graph, so our graph is starting off with the root node, which has the name of A. A has the children of B, C, and D. Now, and then if we said that might make it even clearer. So we have this dot name. Our first root node is going to be A. Its children are B, C, and D. This dot name is referring to B when it comes inside of the actual child node. So once we're inside, we go through our first const child of this dot children, and we call child dot DFS. It's grabbing onto the child node, whatever the child is, and it's calling its method. So all of these nodes that were created, they have the same methods within them. So you're calling child, so it would be b.dfs, and then array. Or let me put DFS. So b.dfs.array, and then after that, it's going through. It's going to be calling e.dfs, and then going through the passing that array, and then the same thing, and then f all the way through until it hits the bottom. Once it hits J, there's nothing else for it to look at, and it's the call stack. It's a limit. It's already gone through everything, and I definitely need to check out if this is a call stack thing. I believe I'm correct.
Okay.
Once it's done with B, E, F, let's go through. Let's just say I, and then J. So it's complete. It's done with all of them. It goes through. It's passed in that array. The current array. So our current array is going to be A, B, E, F, I, J. Right now, like that first iteration through that first stack of calls, it's the first recursive stack of calls. We have an array built up of A, B, E, F, I, J. Now it's calling C. So when it does C.dfs and then passes in that same array, it's just going to pass C onto this block.
Okay.
There's nothing else for it to push. So it's going to start going down D because it started at A, it called B, it called C, it called D. Now in order for it to start executing C, it has to go through E and F. Now in order for it to execute F, it has to go through E. So once E is done, it's going to start executing F. Once F is executed, it's going to go through I, it's going to go through J. It's going to go, after this is all completed and everything's pushed in, it starts executing. The tasks are already there. It starts executing that second branch, which connects to C. Once that's finished and that's pushed onto the array, it goes down to D. Now it has to execute G before it can execute H. So it goes G, it goes down to K, and then it goes back, and then it has time to execute H, and then there's nothing else for it to execute. So it's calling like all three of these. Like in this for loop, it has three different stacks that it's created. It's calling B, C, and D. It's going to execute everything within this first call, and then it's going to move on onto these the next branches.
Okay, this makes so much sense now.
Yeah, it's, and I do want to. I'm not sure if I'm using the right terminology with the call stack, but I'm pretty certain. So if anyone's listening, or if you want to check that out, just so we can double check and make sure I'm not leading people astray, because that definitely happens, especially when you're learning. But does that make sense? And that's how
Yes.
recursion works. So recursion's taking advantage of scoping and just synchronous programming and how things are executed. So there's no we don't have concurrency going on right here. It's happening at the same time. Like the roller coaster ride for B, it has to happen all the way through until we can board on C, and then C has to be done with the ride until we can start boarding D, and then once D goes on, we're going to board on G, and then H can't go until we're done with K, because it has to iterate all the way through that call, because
Mm-hmm.
it's and it is super confusing. Do you want to try to like explain what I explained, and maybe I find that to be one of the best ways to kind of learn something.
Yeah. So, um, the only thing that I want to kind of clarify before explaining is the call stack. So you were saying how it's gonna be created, like how it's being created every time is like once we call the root, or pretty much when like the constructor is created, uh, or actually no, over here, like um, just pretty much whenever we have recursion, you're saying um, like it automatically creates like call stacks for each branch, like that will go for C, F, I, J, and I and J, and then another call stack for this one, and then another call stack down here, another call stack down here. Correct. So like
Yeah,
it.
that's the easiest way to visualize it.
Okay, so it's just like visualization. It's not actually like space in memory that's being occupied, or
No, there's not. There aren't three different call stacks going on.
uh huh.
Um, it's just the way that it's going through. So it's executing everything within like the instance of B. So it goes from A and then it hits B, and then it has to execute everything within like B's scope, or that scope's not the right word to use, but everything that B is connected to, it has to execute all of that until it's able to move on to C. So C is like hasn't necessarily been looked at yet. Like they're happening at different times.
Hmm. Um. Yeah, I don't know if I can visualize that quite clearly yet about how it happens, but it's okay. Um, well, what I understand is that now we start from this that name, that's the root node, that's A. Um, and then over here, then it goes inside this children. The children of A is gonna be B, C, and D. That was inside the this children array. Um, so then what happens is that it then calls the DFS on each of the children of the root node separately in different call stacks, as we're calling it right now. Um, so when it does that, it will recursively push all of the children's of each branch inside the empty array. Um, and the way it does it is by saying, let's say, B dot DFS and then passing the array in again. So and then with the next one, when it finishes up going down the B branch, then it goes to the next branch or the next call stack, which was C, and then it starts adding it to the end of the array. So over here I can complete this array over here. So then what happens next is it's gonna call on the D branch, so it's gonna go d.dfs and then pass in the array. And then what happens is over here, it is gonna add D over here. Then it goes through the children of D, which is g.dfs, and then passes an array, again, the same array. So then it adds G, then it goes the child of G, which is K. So it says k.dfs, passes in same array.
Yeah.
So we add K, and then it goes to the other child of D, which is H. DFS passes an array, and that is how it pushes the children in a depth first method inside the array, the empty array. Correct?
Yeah. And then I'm gonna add this. So while you were talking, I was also looking some stuff up just to make sure we can clarify
Okay.
what we're talking about. And so that is what's happening. And so when a current function is my bad. So when the function makes a nested call, the following happens. The current function is paused. The execution context associated with it is remembered in a special data structure called the execution context stack. The nested call executes, and then after its end, the old execution context is retrieved from the stack, and the outer function is resumed. So I think that's a very complicated way to explain what I was explaining with like having those separate call stacks, which I guess it's a special data structure called the execution context stack. And so it's going to be going through, it's going to execute A, and then once it gets into that DFS, so if you call a.dfs, that's what, that's the root node, call a.dfs, and then pass in an array. It's going to go through, it's going to say, it's going to push into the array whatever that name is. This name would be associated with like the context of A, that which was called. Then it goes through the children. So our data structure, the node has a name and it also has children. It's going to go through each of those children. As soon as it hits that first one, it has to get done executing that first call before it can move on to the second call. Now, when it executes that first call, it just so happens to be calling the same call, but just in a different context. It's calling it on a different branch of this graph, and it goes through. Once it's done all the way down one of these branches, then it's able to go back, and it goes back to the execution context, and it resumes. So it gets down to E. This is put on hold, and then it executes F. Goes down to I. This is put on hold, or J's put on hold. Once it's done with I, it goes back up to F and is like, okay, well, I need to call this now. And then it goes back up, so on and so forth. I think that does, so it's the execution context stack is what kind of makes all this possible. It is pausing the execution of the oncoming functions. Does that answer? Does that make it more confusing?
No, I think that perfectly answers. It just takes me a little time to think about it and like reread this. Do you want to comment this out but keep it on the document?
Yeah.
Okay.
And Yeah, so I just got this. I'll throw the. This is just javascript.info/recursion. Because I just wanted to make sure that I wasn't completely wrong.
Okay. Yeah.
Yeah.
Thank you. It's just the way I learn. I have to reread it and listen to this again after for it to
No,
like
this is really cool
fully.
because I didn't. I'm learning like I'm understanding this as I'm talking. Like I didn't really understand that that's what was happening with recursion. Like I understood how to use it. But the whole thing with the call stack and how it's pausing whatever function is going to be going on like in the future. That's actually pretty cool. I didn't actually realize that until today. So
Okay, great. So I think we can delete this part over here to clean this part a little bit. And so now that we have our DFS function working, I think we can move on to the next part of the problem statement, correct?
yeah, what else do you want to go over?
Just solving the problem. What was the problem? It like what's the solution? Like what are we returning in this problem?
Okay, so that's what the example I kind of showed what
Uh huh.
the return would be.
Uh huh.
We're returning an array. So if we were dealing with this actual graph,
Okay.
and this could be anything, this is basically just kind of this is good practice on understanding how you're iterating through. This isn't like a pathfinding algorithm or anything
Uh huh.
advanced. This is just kind of like the very basic of how you can go through and in order get everything and return the actual values.
Oh,
This
interesting.
is a depth first search. So what a depth first search like means is that it's going from top and then iterating all the way down from left to right normally, instead of going from A and then going B, C, D, and then going, that would be a breadth first search. So this is just the searching algorithm and this is like one of the most basic ways to kind of show how you would go through and just check each of those branches off of each of the nodes from left to right in a depth first search manner.
Oh, okay, perfect. Do you want to run this example just so we can see, like in an example, how it will
Yeah,
return it?
yeah, let's figure out how we
Yeah.
can do that. Okay, so let's see. We're gonna have okay. Just give me a second.
Okay.
Let's get some space. And then for the children, how would I add to the graph? Okay, my graph constructor. We have the node. Children would just be other nodes. So let me create some nodes. Okay. Got
And do you want to just add one more child to like B or C or D so that we have more depth?
Yeah, that'd be fun. Then I feel like I have to. Okay, so add child, and we're gonna put E, and we'll make E. And then we're gonna let our new graph. Okay. So we have all of our nodes. We have A, B, C, D, and E. We created. We added a bunch of children. So A has a child of D, C, and B. B has a child of E. And then if we do let me think. Okay, so we added our children. We have that kind of data structure if we want to. And then if we do a okay, dot push cannot be property push of undefined. This dot children of push. Okay, cannot be property push of undefined. So okay, on this dot children.
Um,
I'm 39. Okay. Dot push new node name. So why is it not start children not push? So when it goes through the first time, we're adding a child. Oh, that's why. I'm like doing way more work than I had to do. Okay. Let me step back. Give me just a. I'm sorry about this. I'm trying to figure out. Okay, so add child is going to be actually pushing in that new node, so I don't have to actually name it. Um, and then first dot add child. We'll call this B. We'll check this to make sure that it's actually running.
Uh-huh.
And then should not push new node.
Probably some stuff undefined.
See, I'm confused why this dot children isn't allowing the push. Because like it's saying it's undefined, but this dot children would be referring to that array. Array has a push method. Do you see the issue? By chance?
Let me see. What about? Well, this has to be a new name. Let's just put this.
It's erroring at the add child.
Let's see if it works. So now there is another issue. Well, it doesn't have any children.
Yeah.
Okay, so
H.
how about?
Oh, I see the error.
Okay.
That was a spelling error. CHILDREN.
Where was
Okay.
it? Where was it?
So it's kind of working. Now at least we have a. Is there any way to clear this out? No.
Can we
Okay,
put
so
console log array over here so it runs once? No.
no, we'd want that to stay in. And it's only so it's returning the array every single time. So every single time it would be returning it.
Uh-huh.
So if we did a so we're I think this has to do on the last return, so it's returning it to itself until the end of the last stack, and then it's returning it to us. So if I were to do let's just say return array. If I just do a return array and then I console log this, it should just do it once. because it's just going to send us what it's returning like at the very end. But let's see.
Okay, cool. And then
Yeah.
what
Yeah. So
about?
when we console log at the end, so that return, it's working the way that the stack is. So it's going through, and it's going to be calling it like for each of those branches that it has. So it has 3 children. And if we do a
Yeah, I'm thinking, how can we add a child to like
so
one of the
depth,
children?
yeah, I can do it. Depth
Okay.
first, and on that we're gonna say children. So that's the node, and that's the child, and then push. No, that already has it. Okay, so that should be fine. A lot of this is just really understanding the data structure, and then children dot push. It has 3 children, so children at index 0, and inside of that we're going to push. We got to push a child onto it. So, okay, I'm trying to wrap my head around this. Like iterating through the graph is one thing, like building the graph is another confusion. So if instead we have our name, we have our child, to add a child, we're just pushing onto it. Now, that's a new node with a name.
Couldn't we do add
Now,
child to this?
each of those children, yeah. So if we just do 0.add child, because it should have that method, and then we'll do B or A B C D E. Let's try this out. That might actually.
Yay! So it's
That's cool.
AB. Yeah, it's exactly.
That's pretty cool, huh?
Yeah. Wow, that was such an aha moment for the entire. A lot of recursion and DFS search. It finally doesn't feel as scary anymore.
No, and we definitely learned together right now.
Yeah.
I was like, oh god, I don't know if this is gonna work. I don't know if this is gonna work. That's pretty cool though. Like, so I mean, that kind of just being able to show, like, we're dealing with nodes and awesome.
Yeah. That was.
So it is working the way that we want it to work.
Yeah.
So if we wanted to add, let's do dot children 0 dot children 0 add child, say F. Yeah, it's working. I think that illustrates this definitely isn't the most efficient way of constructing a graph, we'd want to have a lot more methods. This is definitely very, very basic. We're not. We're just doing a depth first search within a graph, and we have the ability to add child nodes. Um, but I definitely feel like I learned a lot.
Me too.
Um, that's interesting. That's really cool.
That definitely was. Well, thank you so much. We're a little over an hour. Um, but I definitely feel like so refreshed. It's like when you learn something that you had so much trouble learning for a long time.
Oh, it's like getting over that cusp, and that's how you like. I feel like when you're really at the bottom is like when you're about to make the little breakthrough, and then you hit another rock, and you're like, oh God, I thought I understood stuff, and I don't get anything.
Yeah. Oh
But
yeah. Before I forget, I wanted to ask, because I wanted to ask you about the Slack channel for the morning 8 a.m. sessions, for algos. But I was wondering if you want to
yeah,
share it here, or maybe just like type it somewhere on the document as well, like maybe
well,
over here.
yeah, it's. Let me see if I can get a web link for it and invite people. Okay, so link does not expire. If anybody wants to sign up, we go from 8 to 9. That's Central Time. I just moved from California like a couple months ago. Let me pull this up. Code interview. Cool.
Okay, great. So the name of the Slack is Morning Algorithms, right?
Yep.
Okay, great. Sounds great. Well, thank you so much. Uh, this was
Hey, thank you so much. That helped me out a lot having someone that understands it like as well as I did and being able to kind of put our heads together.
yeah. That was really great. And really appreciate your time. I know it was kind of hard for you to come at this time. I hope it's 6:30 at your time right now. I'm not sure which time zone you're on.
Well, it's 8:30 right now.
Oh, it's 8:30. Oh my god. Okay. Uh, I'm so sorry. It's 6:39 over here. So I think that's about it. And again, thank you for joining the session.
Awesome. Thank you for giving me the opportunity to help out. Thank you.
You're welcome. Well, I'll see you in the morning sessions.
Later.
Okay.